Welcome to today's lesson. It's for Tuesday, 10/27. We're going to continue talking about solving quadratic inequalities. And we're taking a look at something like this. Now, two new things here. First of all, I see a negative in the a value. If your a value is negative, we'd rather not work with the negative a value. So what we're going to do is we're going to divide by -1 first from every term. So that's going to turn -2, +2, -7, +7, 3 to -3. And notice it reverses the inequality. That rule from Algebra 1, when you divide by a negative, you reverse the inequality. So we're going to divide by that negative and turn this into a greater than problem. Okay, so what we're going to do is we're going to start by solving using the quadratic formula. (b plus or minus b squared minus 4ac), all of that gets us to square root of 73, and the two answers are 0.4 and -3.9. So those are my two critical values, -3.9 and 0.4. So I'm going to pick some points from each region. -4 is in the left region, 0 can represent the middle region, and 1 just past that 0.4 can represent the region on the right. And when I test each of these numbers, just like we did yesterday, by plugging them in, notice I'm plugging them into the form of it after I've divided by -1. So we're going to plug -4, 0, and 1 into that. So if I plug in -4, I get 6 greater than 0. Yep, works. 0 would give me -3 is not greater than 0. And then you can see 1 also works. So clearly it's the outside regions that work. And so that means my solution would be that x is less than -3.9 or that x is greater than 0.4. I'm going to let you write the answers this way. Now preferably, and for those moving on in math, we really want to see these answers written in this format. Less than -7 minus the square root of 73/4, because that's the exact answer. Or x is greater than -7 plus the square root of 73/4. Instead of seeing the approximate decimal, listing the exact answer. But I will accept this. I won't take points off if you just give me the approximate decimal. And that's really all there is to it, guys. I mean, nothing else is changing. I'm going to show two more examples here, but if you think you're good, you can stop the video now. I'm going to do one with completing the square. There is no negative here, so I don't have to worry about reversing the sign or dividing by anything. But just realize you can solve these by completing the square. With 14, I would add 49 and -49. And when I solve by square roots, I get these two exact answers, these two decimal answers. And I would do the same thing. Test 3 points, one from each region, and I would see the middle region works, which means I'm going to be doing an AND statement. And again, I would like to see that as 7 minus the square root of 78 is less than or equal to x, which is less than or equal to 7 plus the square root of 78, listing the exact answers, but I will give credit for the approximate decimals. Lastly, just to show you one more example for something you're going to do today in the homework, just to help you out a little more. Nothing different really, just how do I approach one like this? I do see a negative in front, and especially on this one I want to take a negative out so that it looks like the conjugate rule. When I divide by a negative, it changes both signs and reverses the inequality to less than. So then I factor and solve. This is a conjugate rule. 11x plus 8, 11x minus 8 gives me -8 11ths and +8 11ths when I solve that using the zero product property. So my test regions, now this is less than -1, so I can just do -1, 0, and then 1, 3 easy numbers. And again, we're testing it into the reduced one, not the original, because we've rearranged our equation now. And when I test it, I see that 0 is the only one of the three that works, which means the middle region works, and I have that exact answer. Rather not see the decimals there, especially there, with that compound inequality and statement. Okay, jump into the homework, doing the same thing, just using completing the square maybe if the numbers work out, quadratic formula if not, especially completing the square if there's an x squared, no number in front of x squared, and the b is even. It's a lot easier to use completing the square. I think easier than quadratic formula. But it's up to you. I'll let you pick which method you use to solve. Okay?